Welcome to SEACO-GULF's YouTube channel, your destination for understanding engineering simulations and real-world applications of computational fluid dynamics or CFD. Okay, so with the help of this presentation, I would like to give the introduction of the CFD and what are the software used. Okay, so first is what is CFD? So the full form of the CFD is Computational Fluid Dynamics. Computational Fluid Dynamics is the science of using numerical analysis and algorithms to solve and analyze problems involving fluid flow, heat transfer, and related physical phenomena. Okay, so that is the CFD. Okay, next one is what are the applications of the CFD. So the application of the CFD is very vast. I have mentioned here few, but it is being used very in various areas. It is being used currently. Okay, like for example, which one is missing, which is the medical. Okay, so in the biomedical, CFD is being used very vastly. Okay, so let's talk about the examples which is being given here, like aerodynamics. So aerodynamics, the applications is in cars, aircraft, drones. Okay, so we analyze the airflow pattern to the cars, aircraft, or drones, or any other flying object, or other things related to the aerodynamics. Next one is for the HVAC. So like for the heating, cooling, and ventilation optimization, we use CFD. Okay, next is for oil and gas. So it is for pipeline flow, safety simulations. Marine, it is used for ship hull design, propulsion efficiency. In industrial, it is used for process optimization and energy savings. Okay, so in the next slide, you can see that there are some pictures of the CFD results. So the first figure is representing the airflow over a car. So specifically, the air is flowing through the car, and with the help of the streamlines, it is being visualized like what is the pattern of the airflow. Okay, next one is the water flow in the pipeline. So like we are analyzing like how the water is flowing inside the pipeline. Okay, so you can see the pattern of the water flow. Then the next one is the example of the HVAC. So specifically like the how the air is circulating in an in an environment, in an arena, you can say. So that is the thing. So it's an example of indoor arena. So that is the thing. So it is like indoor air circulation which is happening. Okay, so these are some of the examples which I have shown you. Like these are like the real examples of the CFD, real CFD results, and like how you will get it. Okay, next one is like why CFD is important. Okay, so first of all, CFD is like it reduces the cost by minimizing physical prototypes. So for example, you wanted to make an you wanted to apply for the HVAC application of the HVAC. Okay, so you don't know like how much flow rate you have to give, and what will be the optimum flow rate, and how much cooling is being required in an environment. All right, so beforehand, with the help of the CFD, we can generate a virtual environment, we can create a 3D model, and there with the help of the CFD analysis, we can determine like, okay, these are the things which is being required. These are the temperatures, these are the flow rates which will be required. These are so like for cooling a space. Okay, for cooling a space. All right, but if you do not use CFD, you will be like guessing, or it will if you go for the experimental also, it will be very costly. Okay, so that's why CFD is very important in all those types of cases. All right, like for the design optimization, as we have seen in the here in the car also, like how much drag is being made by the air when the car is flying. So with the help of the 3D model, with the help of the CFD, we can make the changes in the design. Okay, and we can get the optimum design, so that the minimum drag can be we can get minimum drag. Okay, when the car is flying. Okay, same is like for the flow, like we have talked here, like in the oil and gas. So like the when the through the pipeline, when this oil and gas is being supplied, they are supplied on a very high pressure. Okay, so like what is the optimum pressure so that we can supply, at which we can supply these oil and gas, okay, that we can beforehand find with the help of the CFD analysis. All right, so that is the part. So like the second one which I have told you, like same saves time in design iterations, improves efficiency and performance, and third one, last one is enables testing in conditions difficult to replicate physically. Yes, because physically there are some conditions which you cannot replicate. Okay, so with the help of the CFD you can replicate, make a model, do a CFD analysis, and with the help of the analysis of the results which you call the post processing, so with the help of that you can get the results which are physically very difficult to perform, like before the CFD, it is the only the way was to perform an experiment, and only with the help of the experiment you can get the results, and you can check, okay, this is the optimum, this is not working, this is working. All right, but that is very costly. First you have to make an physical environment and all the things to test, okay, that is very costly. But CFD has made all those things very easy and very very it can be done in a very minimum cost. Okay, that is the thing. All right, next one is what are the software used in the CFD. So the usual which is industry standard is ANSYS Fluent. Okay, so it is multi-physics and industry standard CFD tool. OpenFOAM. So OpenFOAM is an open source customizable platform. So OpenFOAM is like, you do not require licenses because it's open source, and you can customize the solver as your application. If you are making something new, okay, or your problem requires something new application, as a pre-made solver is not able to perform the is not able to give you the results which is required. So you can customize as per your requirement, and you can do it, okay, because all those things are accessible, all those solvers are accessible and can be edited. Okay, that is the thing. So OpenFOAM is your ParaView is like advanced visualization and post processing. So basically ParaView is being used for post processing the results of the OpenFOAM simulations. Okay, other tools are like Stars ACM Plus, COMSOL, Autodesk, CFD. Okay, so these are also used for the CFD analysis. Okay, so these are the softwares. Now new softwares are also coming. All right, but yeah, that is the part. Now about our work, okay, about our SEACO-GULF CFD work. So where we work, all right, in which areas we apply CFD, that is the part. So we work in the field of HVAC, oil and gas, marine and industrial applications. In the coming video I will try to show you like what are the applications we have done. All right, so first regarding the HVAC, it is like the cooling of of different arena, okay, that we have done, we apply CFD there. Then it is like the thermal efficiency of the data center cooling, okay, that is the part. Then then in the like oil and gas application, so with the help of the pressures we would like, then we use those pressure results for the FE analysis also. So that is the part we apply. All right, then like second one is like we have very advanced simulation capabilities, using multiple platforms. We use multiple platforms to run the simulations. All right, and the second one is like we always committed for new innovations, for accuracy and efficiency. Okay, we are always committed to give very accurate results, and as efficient as it can be, and we try to apply as new innovation as we can. Okay, and our clients are basically in the Gulf region, and global clients also. We are also expanding the our work. Okay, so that is the our about our CFD work. Okay, so in the conclusion part, it is CFD is a powerful tool for modern engineering. Multiple software platforms allow flexibility and precision. Our company, SEACO-GULF, leverages CFD to deliver real-world solutions for more engineering insights, for more CFD applications, please subscribe our channel. And in the coming videos we'll be seeing like how the applications of the CFD is being applied, and we'll be giving some type of tutorials also. All right, so yeah, thank you for watching.